Good morning everyone. Myself Dr. N.Sivashanmugam, Assistant Professor, School of Computer Science, Tamil Nadu Open University, Chennai. Today we are going to see about OSI reference model. OSI reference model is the network system model used in all type of networks. That is ISO, OSI and IOS are three types of similar acronym. That is ISO means International Standard Organization and OSI means Open System Interconnect, that is reference model, and IOS means Inter-Networked Operating System. What is OSI reference model? When it was created? The OSI created and released the OSI reference model in 1984 to provide vendors with a set of standards to ensure greater compatibility and interoperability between various types of network technologies. OSI reference model reduces complexity, standardizes interface, facilitates modular engineering, ensures interoperable technology, accelerates evolution and simplifies teaching and learning. Next, we are going to see what are all the layers in the OSI model. There are 7 layers in OSI model. That is, it starts from, we have to read from the descending order. That is physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. What are the characteristics and advantages of the OSI reference model? It will reduce complexity, standardize the interfaces between two different networks or two different systems, facilitate modular engineering, that is step-by-step engineering, and ensures interoperable technology, accelerates evolution, simplifies teaching and learning methods. Then see all the, now you are going to see the different type, what is the use of the different layers. We start with application layer. What application layer will do? Application layer is used to process the network applications. It provides service to the application processes such as, that is electronic mail, that is file transfer, data transfer, terminal emulation and end-to-end connectivity, that is user end. We can call it as also a desktop. What we are seeing in front of the in the desktop display mode, that is application. Next we go to the presentation layer, that is data representation. Ensures data is readable by the receiving system. It formats the data, it structures the data, negotiates the transfer syntax for application layer. Then we go to the session layer. What session layer will do? That is inter-host communication. It establishes, manages and terminates session between applications. It do the operations of termination and manages the operation, inter-host communication operations. Next we see about transport layer. That is end-to-end connections. Handles transportation issues between hosts. Ensures data transport reliability. Establishes, maintains and terminates virtual circuits, provide reliability through fault detection and recovery of the information from data flow, that is contingency and controlling data. All these things are done by transport layer. Next we go to the network layer, that is data delivery. It is also called data delivery. It provides connectivity and path selection between two host systems, two different systems. That is connection enabled between two systems. It will hold the path and it will create the path and it will send the data to the host system. Then routes the data packet. It will found the shortest route, which is the shortest route to transfer the data from one place to another place. It will fix that shortest route and it send the data to the delivery end. And then it selects the best path, that is shortest path. For that there are so many algorithms, shortest path first algorithm, first come first serve algorithm, like this they are used some algorithms. to enable the network delivery, data delivery in the network layer. Next, we move to the data link layer. Access to the media defines how data is formatted and transmitted, and how access to the network control. The data link layer will create header with the above 7 layers, that is header of the data link layer, and header of network layer, transport layer, session layer, presentation, application, header, and then user data. It maintains the packets. It will separate into our data, what data we are sending, that was divided into packets, bits, or whatever it may be, and then it formatted into some standard format, that is header. Header means header all the 7 layers of the header, and represent all the 7 layers, and then go to the delivery and transfer the data to the delivery end. Next, we go to the transmission, that means physical layer, binary transmission. This is the procedure, electronic mechanism procedure, that is functional specification for activating and maintaining and activating the connection, and deactivating the physical link, that is physical layer. Physical layer means what type of medium we are going to send the data from one place to another place. It will manage all those things, that is transferring data, that is the medium of transfer, which medium, that is maybe guided or unguided, that is wireless or wired, like that it will manage. Next, we see the data encryption, how the 7 layers function and how it was sent to the receiver. This is sender, that is layer 1 data link layer, then layer 2, that is header plus layer 3, and header plus layer 4, 3 layers, and header plus 6 and 5 and layer 5, and then header layer 6 and header layer 7, and user data accordingly it will enclose with the data streams, and it will send to the delivery end. The delivery end, how they are receiving the same pattern, that is from physical layer. There is 7 layer, that is 6 layer is included in this, and in network layer 5 layers, that is header. It will the data link layer will convert to the user format, and the network layer will support with the help of protocols, and the transport layer, session layer, presentation, and user end. It will come to the data, that is original data from the sender to the is received at the receiver end. Then it is a peer-to-peer connection, that is sender and receiver. See, this starts from application, presentation, session, transport, network, data link layer, physical layer. It was transmitted as a segment, packet, frame, bits in the network environment, that is maybe a satellite or wireless or wired, whatever it may be. The data is transferred in the globe, open through some wired or wireless medium, and again it was converted into and sent to the, that is start from physical data, network, transport, session, presentation, application, that is receiver end. Well, by the way, the data was transferred by using this OSI model. Next, advantage. What are the advantages of OSI model? OSI model clearly defines the service, interface, and protocols. It explains which layer services are supported. It also explains how the procedure placed about specific layer will create its services, and how it can help the protocol to do their tasks. The protocols of the OSI model are exceptionally private and can be returned with other appropriate protocol quickly. It is a general model. It provides connection oriented and connectionless. That is, I said, connection oriented means guided wired medium, and connectionless means is wireless medium. It will provide all those things because the layered architecture following the abstraction service, and the change appearing of one layer does not force the other. It gives more security and flexibility, unlike having all features accumulate together into an individual layer. Next, we see about disadvantages. What are the demerits of the OSI reference model? The session and presentation layers are not much used. That is not more important, but it will use. For some purpose, from advanced features, we use that presentation in session layers. The OSI model was developed first and then the protocol was created to conform the network architecture requirement. Thus, in real life, there is an issue of proper protocol in the model. The OSI layer are independent. OSI layer cannot operate in parallel. Each approaching layer requires waiting to get data for its predecessor layer. For instance, the application layer gets the data from the presentation. The presentation layer need to wait to get data from the session layer, etc. Likewise, they have to wait next layer, that is transport layer, network layer, data, like that. They have to wait for certain period of time. The performance of transmission protocol (TCP) was used. An internet protocol (TCP) was earlierly it was released in the model. Thus, some organizations are certainly using this. Few layers such as presentation layer, session layer have very few services. And next, I will summarize the OSI model. OSI reference model reduce complexity, standardize interface, facilitate modular engineering, ensure interoperable technology, accelerate evolution, simplifies teaching and learning. And second one, each layer of OSI model, that is, has a set of unique functions. 7 layers of OSI model are the application, presentation, session, transport, network, data link and physical layer. Encapsulation is the process in which data is wrapped, that is, data is converted into stream, data stream. That is, we have to add the address, we have to add the header, we have to start address and end address, where sender address and receiving address, we have to include all the, you have to incorporate all the data in the data packets. Then only it will reach the destination without any error. Encapsulation process is a process in which data is wrapped in a particular protocol header before network transit. I think this is a small lecture for about OSI model, and I will come with another topic in future. Thank you. Dear learners, and second reference model we are going to see now, that is TCP/IP. There are two reference models. First, earlierly we seen OSI model, that is Open System Interconnection reference model. Now TCP, Transmission Control Internet Protocol reference model. Reference model. TCP reference model is a 4-layer suite of communication protocol. It was developed by Department of Defense (DoD) in 1960. It is named after two main protocols that are used in the model, that is namely TCP and IP. TCP means Transmission Control Protocol and IP means Internet Protocol. The two protocols are used in this TCP/IP reference model. Students, the four layers of TCP/IP protocols are host to network protocol. It means it is the lowest layer that is concerned with the physical transmission of data. TCP/IP does not specifically define any protocol here, but supports all the standard protocol. The next layer was Internet layer. It defines the protocols for logical transmission of data over the network. The main protocol in this layer, that is Internet protocol, is used, and it is also supported by the protocols ICMP, IGMP, RA, reverse ARP, address resolution protocol. Then the third layer is transport layer. It is responsible for error-free end-to-end delivery of data. The protocol defined here are Transmission Control Protocol and User Datagram Protocol. The final layer, application layer. This is the topmost layer and defines the interface of host program with the transport layer services. This layer includes all high-level protocols like Telnet, DNS, Domain Name Service, HTTP, Hypertext Transmission Protocol, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol, etc. It will look after all those this. Now we are going to see the difference between OSI model and TCP/IP model. What is OSI model do and what is TCP/IP model do? OSI represents open system interconnection and TCP model represents transmission control protocol. One second. And OSI is a generic protocol independent standard. It is acting as an interconnection gateway between network and final user. But TCP/IP model depends on standard protocol about which the computer network has created. It is a connection protocol that assigns the network of hosts over the internet. The OSI model was developed first and then the protocols were created to fit the network architecture needs. The protocols in TCP/IP, the protocols were created first and then built the TCP/IP model. In OSI model, it provides quality services, does not provide quality services. That is, in TCP/IP does not produce quality of services. In OSI model defines administration, interfaces and conventions. It describes clearly which layer provides services, but it does not maintain services, interface and protocols. It is difficult as distinguished by TCP/IP. It is simpler than OSI model. It provides both connections and connectionless oriented transmission in the network layer. However, only connection-oriented transmission is in the transport layer. In TCP/IP, it provides connectionless transmission in the network layer and support connections and connectionless transmission in transport layer. In OSI model, it only support connectionless and connection-oriented. It only in TCP/IP, it only connectionless connection will be enabled. It uses a horizontal approach and it uses vertical approach. The smallest size of OSI header is 5 byte, but in TCP/IP, the smallest of TCP header is 20 bytes. It's much higher than the OSI model. The protocols are unknown in the OSI model are returned while the technology modifies. But in TCP/IP, the protocols is not difficult. We can create our own protocols to use as a TCP/IP protocols for transmitting data one place to another place. There are some advantages in TCP/IP protocol suite. They are: it is an industry standard model that can be effectively deployed in the practical networking problem. It is interoperable, that is, it allows cross-platform communication among heterogeneous network. It is an open protocol suite. It does not owned by any particular institute and so can be used by any individual or organization. It is a scalable and it is used in client server architecture. This allows network to be added without disturbing the current services. It assigns an IP address to which computer or network, thus making each device to be identifiable over the network. It assigns each site a domain name. It provides name and address resolution services. These are the some points for advantages of the TCP/IP protocol. There are some disadvantages also in TCP/IP suite. It is not a generic in nature, so it fails to represent any protocol stack other than TCP/IP suite. For example, it cannot describe the Bluetooth connection. TCP will not encourage or entertain Bluetooth connection. It does not clearly separate the concept of services, interfaces, protocols, so it is not suitable to describe new technologies in the new networks. Next one, it does not distinguish between the data link and physical layer, which has very different functionalities. The data link layer should concern with the transmission of frames. On the other hand, the physical layer should lay down the physical characteristics of transmission. That is, physical characteristics with this guided medium, unguided medium, or wired or wireless, and what type of if it is wireless, means what type of transmission, that is infrared, ultraviolet, or radio wave, whichever transmission mode we can choose. And wired means guided means copper, coaxial, like that cable. It depends upon the cable, it varies. The proper model should segregate two layers. It was originally designed and implemented for wide area network, only for WAN. It is not optimized for small area, that is local area network, MAN, metropolitan area network, or personal area network. It is a suite of protocol. TCP and IP were carefully designed and well implemented. Some of other protocols were developed ad hoc and so to prove to be unsuitable in long run. However, due to popularity of the model, these protocols are being used even 30-40 years after their introduction.